later on once we're all through. So cool. Also, I need to try to share the screen here. There we go. All righty. I tell you what, it's hard to believe we're kind of wrapping things up. This is going to serve as our last, kind of scheduled time to meet. So that's kind of exciting. Again, it's amazing how quickly we've moved along here. We covered a lot, I think, a lot of different, good variety of analyses. Looked at a lot of different data sets, and everything that we're doing again is sort of cutting edge. It's in practice stuff that you could use. Certainly as you adopt these new methods, or any method really for that matter, you'll probably fall into a kind of a pattern of how you do it and how you like to do each method. You'll probably, as you use data sets, find a method that is sort of your way to handle data and manage it. Different again, ways to follow these techniques. So that's one of the nice things about research, is that it's sort of individualized, where we have things that we test, and we have kind of the standards and the things that tend to be the best practice. But the reality as a researcher is that as you're doing the research, you're very often doing your research. It's your approach and it's your process that you refine over time. So it's one of the challenges, maybe, that, like, I know I experience it sometimes, where I'll work with a researcher, or we'll collaborate on a paper or a data set, and they'll have one approach to how they do an analysis, and I'll have my approach. And generally we arrive at the same conclusions, but it's okay to have kind of formed your own method. So that's one of the kind of the neat things, to do with this. At the end of the day, I'll say this though: you do have to defend yourself. So you do have to, if you come up with a conclusion and you use a statistical method or some type of an analysis, somebody certainly may raise their hand and say, "Hey, how exactly do you come to that conclusion? Show me, your evidence, or show me what led you to, come up with this." And kind of puts you on the spot, especially if you're just fumbling around and not really kind of sure of what you're doing. But at the same time, if you have that type of pressure, it makes you a better researcher, if you're going to have to kind of explain, the results, or explain kind of how you got there. So at any rate, this is kind of our last little session together. We'll just see how we do, and kind of where we go with tonight. And again, as always, if you have questions, feel free to ask, and kind of we'll go from there. Um, just some administrative sort of bookkeeping types of stuff. We're in, again, the last couple weeks here of the class. I'm catching up on the grading, so I know I'm about a week or so out of sync here. So I've got a lot of that to do tonight, last week, and this week, in terms of the work that we're doing. We're wrapping up. Last night we should have finished up the cluster analysis homework. I hope you found cluster analysis to be kind of fun. You get to look at pictures. There's not like a lot of, I don't know, it's different, because it seems like the process is pretty, I want to say, easy. I mean, there's not a lot to it, but the benefits that you yield are oftentimes interesting groups of consumers. So what we're doing is we're exploring, and we're coming up with market segments a lot of times, or we're just organizing our subjects in them, or classifying them into groups. So the homework assignment has you by the respondents into clusters or groups, And then what you can do, and the assignment had you sort of confirm, and it's a bit rigged. The system's rigged a little bit, but that's okay. Confirm your clusters by using discriminant analysis to sort of confirm those. So we'll walk through that a little bit, in terms of a review. But being able to sort of interchange and sort of go from one method, like a cluster analysis, to a discriminant analysis is okay. It's kind of good to be able to confirm your results and see some synergy across methods, actually. There are certainly plenty of times when you're faced with an analysis problem and you're not 100% sure on the method you want to use to solve it. So you may actually like run 2 or 3 different methods and determine a method that tells the best story or the most clear story, I guess. I had a paper not too long ago, about, I don't know, maybe 3 or 4 months ago, that I was working on, where we ran the analysis doing a structural equation model, an SEM, which is actually in the last chapter of the book. And then we decided a traditional SEM, and then we decided to run it using a partial least squared SEM, which is a very different, use different software for it. It's a different approach. They're different fit statistics. But, they both kind of do the same thing, but they're both different methodological approaches. And, we weren't really sure which method would explain the data best in the most clearest way. So we ran it a couple different ways. And that might be one of the things that you do. You can do a discriminant analysis, for instance, with two levels, or you can run maybe a logistic regression. And those are two very different variates that are created, but they sort of get around the same topic, if you will. They're kind of the same, they achieve the same goal, but they use two different methods. And so being able to kind of be flexible and try multiple methods is kind of a good thing. So that's one of the things you'll notice in these homework assignments. You'll certainly notice it in the final exam, but in these homework assignments, you may notice where you do some analysis one way, and then you use those results and apply a different analysis to it, and sort of build on your story by using some different methodological approaches. So that's not meant to confuse people. It's not meant to make things abnormally difficult. It sort of reflects kind of a lot of research projects where you start down one road and eventually you commit to doing 3 or 4 different analyses. You might not report them all. You certainly may not tell the client you did all this stuff, but what you're trying to achieve is the best, cleanest story that the data will tell you. And so that's kind of where you are. And so that's kind of, I don't know, I think it's kind of fun. It tests your flexibility and strength in using your methods. So, and also it gives you an opportunity to practice some things you might not normally do, whatever. So, anyways, looking at the schedule, then we're wrapping content up this week. Again, we're doing MANOVA. I think what you're going to find is MANOVA is not conceptually very different from ANOVA. And so I know you've probably done ANOVAs before, maybe with Dr. Hare and in some other classes. So it's kind of like dusting off your notes for that and just kind of remembering this idea of between group differences and testing between groups, and some experimental design. There's a level of 2 of complexity that's added when we do a MANOVA because we're adding variables. And so we're either adding dependent variables or we're adding factor variables. So we can have interactions between factors that are there as well. Also, I don't go through it in the assignment and I don't go through it in the final, and I don't go through it in the videos or anything, but you can also use MANOVA effectively if you're testing for mediation and moderation. So we talked about mediation and moderation back when we did regression, and Karen and Barron and Kenny's paper and a lot of the research tradition suggests that you do a series of regressions to test mediation and moderation, but you can also do it in and within a MANOVA as well when you look at the interaction effects of factors. So if you have non-metric variables that you think are contributing to an interaction, like for instance a moderating, one might be a moderating variable. If that moderating variable is a non-metric, so if it's dichotomous or if it has levels, then you would probably want to use a MANOVA instead of a regression to test for that moderation or perhaps even mediation. And so at the end of the chapter, there's a section there on those tests for mediation and moderation, which are worth kind of knowing that they're there. Again, we're not really that's a little bit of a deeper push than I think we need to cover maybe necessarily this week or in this class, and that's okay. I suggested early before the semester started, if you don't have to do this, but if you're so inclined to buy a copy, purchase a copy of the textbook, or get a copy of one of the earlier editions because they're not that expensive, then this is really a good manual to have on your bookshelf to refer to in the future. So again, I don't make any money. I'm not a salesman for the book, but I have a couple copies of it that I've used over the years. And so going back and being able to have that resource may be helpful. Okay, so do you have any questions like right now? Yeah, Riley.
Sorry, it takes a while for me to unmute.
That's
I'm just wondering about like the final. I know you sent out that email.
sure.
I'm kind of just concerned with like the formatting and like, is there going to be a paper as well with that? And then also like the dates, like, are you flexible? Does it have to be Monday through Wednesday?
It does not have to be Monday through Wednesday. I'm going to be in a car traveling a little bit on Thursday and some on Friday during the day. So I'm free Thursday and Friday. It's a little, we just have to work out the schedule. So there are 8 students in this class. And so it can be during the day. It can be, I know sometimes if you're working after hours may be difficult. In the past, we've always done it like right here in the offices, obviously kind of just like a face-to-face thing. And we've done it just, we've just kind of blocked out times and people signed up for a time. But again, with only 8 in the class, it seems like if you send me some times that work for you, we'll just work out a schedule together. I know that one time slot, Wednesday at 7 p.m. has been selected. So that would be maybe off the charts, but any other time would be good. But let's walk through the final exam, just to kind of answer any questions and maybe give you some confidence in kind of where we are with it and what you can expect. So the final exam is here, and then there's this final exam, the Word document you can pull up, or it's available when you want to look at it. And so basically you're going to have a data set and you're going to execute a number of analyses on the data set. So that's mainly on page 2. You'll see those specific, the case evaluation, the specific things to do. On the first page, it kind of gives you a review of what it is. So there's the oral exam part. And what we do in the oral exam is I'll more or less walk through the questions on page 2. More or less walk through the questions and sort of ask you, to kind of talk about, like this first question, it seems like this is going to be a factor analysis on restaurant characteristics X12 to X21. So I'll ask you about, kind of what you found, what type of factors you found, what your process was, what you looked for. Well, I'll ask you, kind of the adequacy of the data, and whether it's suitable, the variables were suitable, what you'd look for in terms of that, like the KMO stuff and all of that. We'll talk about factor loadings, what's good, what's bad, what's not good, how you choose your factors, what criteria you kind of use. Did you use an eigenvalue rule? All the things that we would talk about in doing an analysis for factor analysis. We'll walk through that. And, it's kind of up to you to talk about, well, the best of your ability, how you did your factor analysis and what you thought was important and what you looked for, and kind of justify your process in doing it. It's not like, and again, like with these homework assignments, and like this is a good example where I don't sit down and expect, I don't necessarily sit down and say, well, this question you should yield 4 factors and that's either a right answer or a wrong answer. It's really more your process of doing the research and whether you kind of understand why we're doing these methods and what to look for, and whether whether the research was done effectively or not. That's basically what it is. And you can kind of go through each of these questions, and each one of them, some of them build on the others. So in question number 2, we're looking at some outcome variables, and when we're looking at explanation, like can these variables be explained, or can they explain the restaurant characteristics, the factors that you created in number 1, probably going to do a regression of some type, on that. So there might be a series of regressions because you have a series of factors, or you have several factors. So you might do multiple regressions, or something along those lines. And that would not be unexpected there. So the oral part then is really, it's more of a kind of a conversation, but you are kind of explaining yourself and defending your method and kind of walking through, and I'll ask questions about kind of what you're looking for along the line, making sure that appropriate assumptions are either investigated or met or discussed. So looking for outliers, looking for multicollinearity, all those types of things that we look for, you should do in advance. And that's it. We got this last question at the end, which is really kind of a summation. Like if you were sitting in front of a client, you've got this data about kind of the business characteristics, and you've got this data about customers in this product category, and you're advising one of the managers of one of these businesses. This is kind of like the interaction part that you would have with a client. So there's analysis, but there's also this, at some point you've got to be able to explain to somebody who's not a stats person kind of what's going on. Okay, so this is the oral presentation, or that's kind of a discussion of the oral part. Now, along with this, what you should do is create a written document. And so, before we meet orally, you'll have this written document done and you should send it to me or submit it at the time or before your oral presentation. Um, so so within this, you know, the final exam is composed of two parts: the oral review of your research process, and then second, a hard copy of, you know, kind of those 7 questions down below, kind of walking through that. In the written part, you know, if you follow or if you think about these 3 sort of big pieces, like part 1, part 2, part 3. Part 1 is basically an executive summary, which is in essence that question number 7. And then part 2 is your data assessment, which is basically the questions 1 through 6. You know, and you don't have to go into enormous detail here, but you want to sort of kind of in a, you know, walk through sort of what you did and the analysis and maybe some conclusions that you have. Bring into that some tables that you feel are appropriate from your from the output. And then if you feel it's necessary, or if you want to, it's not a bad idea. If you want to do more tables and such, you can have those in sort of part 3, which would be like an appendix. But make sure the appendix is not simply your output file, cut it and paste it in. You know, make sure if you do that appendix that you know, you're judicious about what you put in it, and that it's not just table after table after table, just ad nauseum. Make sure that if you're using that, you know, put it in the context of those questions. So, and you can call those tables out within the body of part 2 here, if you will, the data assessment. Okay, so by the time that we sit down and talk with the oral part, you know, you'll have this written part done, and that will help guide you and give you confidence in kind of our conversation. You know, it's not something where when we're having our oral exam, you're reading verbatim from your report necessarily. It's kind of like, I need to know that you're confident enough with your work just to talk about it and be able to kind of explain what you did and why you did it. Okay, so that's it. I mean, it's it can seem a bit daunting, but the data set's pretty clean. It's you know, it's not a bad data set to work with. There's not too much in it that's too crazy, to be honest. It'll be fun to work with. All the things that we do that you've done here, you will have done a homework assignment on. So, and it's certainly all explained in the text and in what we've done in the class. So there's nothing, you know, it's open book, obviously. So you'll have plenty of opportunity to work on this. It's not open collaboration with your friends and classmates. It's your own work. Um, but that's kind of it. Okay, so that does this help Riley or anybody else? I mean, is this provide some guidance?
Yeah, it definitely provides guidance. Just kind of overwhelmed, but
Well, it is a final exam, and
yeah.
you know, I mean, it kind of summarizes what we've done in the course. So, and it's, you know, we have, you know, you've got time. I mean, you've got some time. So just depending on when we schedule, a week to a week and a half or so of time to do it. There's not really much else. You know, there's not another assignment, you know, like number crunching type of assignment to do here. So, you know, I guess if you have questions as you're working through it, you know, I can certainly answer questions on, you know, if something is confusing or the wording of a question is vague. I don't want that. Please ask, you know, for sure. And we'll work through any questions that you have as we get going. Okay, good. All right. I'm not hearing more questions, but so final exam is there. Again, this last section on Manova is there with some videos um, that are there as well. You know, with all of these things, three big resources. Obviously, the class, I guess, videos may help. The textbook certainly helps. External, external videos. If you just want to look up the subject and hear a different explanation of it, that would certainly be good too. There are a lot of resources. These techniques, like the others, Manova, like the other techniques, are pretty well established. So there should be some good opportunities to kind of walk through those. All right. All right, so let's just spend a little bit of time. We can talk about, actually I have up here, this is the Chuck Wagon data set. So this is for the final exam. You guys can download this, of course. So it's a good size, it's a good data set, like I said. Some clusters, you'll create some clusters, you'll do some factor analysis. First few, these variables here. So just so you know, and again, you'll see this as you kind of come up with it. X0. This is it's a dichotomous. It's a dummy variable, like, or it's just an indicator variable. It asks, what restaurant did you last go to, or thinking of of a restaurant, either Charlie's or Jose's. You're answering the questions on the restaurant questions on the survey relative to one of these two restaurants. So last time I went to Charlie's, and that's the restaurant I kind of go to. So I'm going to answer the questions in a frame of Charlie. So that's one thing to know, like, which restaurant did you, in fact, the question itself, I think, even asks, I'm not sure if I can pull this label up. Mexican restaurant most recently eaten at, one or the other. And then the first questions here deal with sort of personality or preference. So this is like consumer preference data, about like what the consumer likes and what not. The next several questions deal with the actual restaurant performance. Again, taking into context where you most recently ate at. So speed of service, proper food temperature, and so on. And then we have some outcome variables. So satisfaction, likelihood to return, likelihood to recommend. We have this this 1 through 5 scale. So it's a scale variable on frequency, but we also have that same variable 25 coded into a 3-level. So this has been created for you, where this is a like an ordinal type of a scale, generated from the frequency X25. So you'll actually use this X coded in one of the questions in the assignment. And then, we have some other things here that we're dealing with in terms of some advertising and some other stuff that's here, and then some demographic variables as well. So those are the variables that you'll have, with you. This last one I created earlier just because I was playing around with the data a little bit, just making sure it still works right. And you can kind of go from there. Okay, so fun data set, good data set. I think sample size is pretty solid, 405 respondents. So you got a good size sample. And so you should be good to go with that. Um, with the cluster, the cluster assignment, I thought we'd spend just a minute or two maybe looking at this cluster assignment that we had. Um, let's just bear with me a second. I'm going to just pull up that assignment over here. Sorry, I should have probably had this up and ready. So what we want to do, so this is our data set. And again, this is another sort of, it's another type of data set that collects data on social and political perspectives. This one happens to also include data associated with brands. So brand attachment is actually data that's embedded in this as well. We don't really use that here, I don't think. Oh yeah, we do. Yeah, for the fruit candy and the Wendy's question, manager question. But basically what we're going to do is, like, we want to try to group customers or respondents in a certain way, and this is exploratory. So run a hierarchical cluster analysis, and not a lot of like, I mean, I know there's not like a lot of options here. We can choose a cluster method and a measurement method. And you can try a couple of different methods here too, just to see if you kind of interpret something differently. If as you go through here, there's not going to be a lot of strong conclusions in terms of what's best and what's not, other than some trial and error and some things that may work better for you. And in terms of the distance measures, but then also the clustering method as well. So that's something to play around with. The plots, again, icicle plots are very difficult to interpret. Dendrograms are difficult to interpret too, but they're what we generally kind of look for in this first analysis. You can run some of these matrices. You can ask for a cluster membership. But to be honest, if it's exploratory, you may not have anything in here. This might be something that you're just not even looking at, and you just might do none there. This agglomeration schedule, again, I think you'll find that it's a little clunky and really long if you do it, because this is a big data set. This is like 780 or 800 or something like that respondents. And with the way this works is one respondent is entered into the system, and then a second one is entered, and their distances are calculated based on the variables that you input. The various, so a new variate's created and a score is created, and then these centroids are formed. So you'll have 780 or whatever the n is. You'll have that many iterations that are performed, and through the hierarchical method. And so that's the agglomeration then schedule. It indicates when each respondent is entered and then when they're reevaluated throughout the entire process. So it's very cumbersome to kind of follow, and I'm not really sure people get a lot of information out of those. You may find some indicators of outliers in the agglomeration schedule, but again, if you're kind of looking at outliers in advance, you may catch them. So yeah, and that's another thing. Remember that outliers matter. So you could kind of go through. I've already done a Mahalanobis distance squared analysis for this data, so I've selected some, or deselected, I guess, some respondents based on that. Another thing that you can kind of do here at this point, because this is a sufficiently large data set, what you probably should do, or what was likely to be helpful, is to only take a random sample of this very large set. So you may only want maybe 20%, 30%, or something like that of the entire data set, it'll be easier to interpret the the dendrogram. Also, our idea here is to create the clusters and then do like a confirmatory analysis using k-means or a two-step, clustering type of an analysis to confirm our group memberships. If you go through all those steps, that's great. But honestly, at this point, again, we don't need the whole sample. We probably just need a smaller subset of the sample. So what you can do, and again, I'm just going to jump out of this just for a second. We'll come back to it, but go under data and then select cases. Now I have here already a conditional selection for Mahalo for the, to account for our outliers. Could sort of go away from that a little bit just for this early work and do a sample. And again, I had this earlier where we're just going to randomly select 20% of the cases and do this initial kind of exploratory stuff with a smaller set. So we'll do that, and we'll go to classify again, hierarchical, and we're still here. And again, if you want to check these, we can. I don't even know that we need to assign cluster membership for this. Dendrogram, fantastic. Play around with the methods. Identify those if you think are good. If you transformation of the variables is something good to do, we can go ahead and do a z-score transformation. Now, all of these variables should be all in the same scale. So I don't think there are any scale issues where I'm dealing with really widely different scales. So the results probably won't be that much different than otherwise. But absolutely, we can do a z-score standardization, and that may be beneficial here. Again, at this point, I'm doing real exploratory stuff, so I'm not saving group membership, but you could, but again, I'm not really too worried about that. Okay, so we'll run it, we'll do okay. And I've got all kinds of, again, we asked for this, so it actually pulled out 179 respondents out of the total. So we randomly drew 179. This is, and again, so stage one, we had our first clusters entered, 151. And maybe 176, and then 151 should appear again in stage 23, because whoever came into stage 23, see there's 151, 179, whatever happened before here caused these respondents to get moved to a different cluster. So yeah, so that kind of is the pattern, but it's hard to interpret, right? It's really kind of hard to interpret when we've got all these. Okay, so then we've got our dendrogram. Again, what I kind of do with this, you don't have to, but I usually take this and I try to put it into some other type of a document. I had done it earlier where I dropped it into like a Word document here, just to be able to see things a little bit better. You can kind of do whatever method. Yeah. So what I did earlier and what I did now is pretty much the same thing, and kind of here's the interpretation. We got this grouping over here, and then we sort of have some groupings here. We've got some in the middle. We could use these like 1, 2, maybe three large groups here. Something along those lines. It doesn't seem like we would be at 2, maybe 3. This one where there's a single line going down, that may be an outlier. So we could actually go and investigate that case. That could actually be just an outlier sitting there, and causing this one drop all the way down to the bottom. That's probably what's happening with that one respondent there. But we could also say 1, 2, maybe 3, 4, 5, 6. So we could go from 3 to 6, probably, something like that. Now, what are we going to learn from this? Not a heck of a lot. It's a visualization to kind of give us a guide post and just kind of see how dispersed the respondents are on these particular variables. It may be that these variables aren't good or are good. We don't know how good these variables are necessarily in grouping our respondents. We had 5 or 6 or 7 variables or whatnot sort of identified. And we want to know eventually whether those variables were good or not. And so we're going to do that in our k-means process. And the k-means or that method of clustering forms clusters through the variates or through what's created with the actual variables. Not the subject so much, but the variables that we chose. So remember, these analyses, or this analysis here, we're using these variables that we had determined earlier that we were told to use. And so what we'll do in k-means is really look at each case relative to the weights and the scores that are created for each of these variables. And each centroid, so we'll have a number of variables. We'll have to determine what those are. We'll tell k-means how many clusters or how many clusters we actually want. And then for each cluster, we'll have a score for each of these variables. So it's a little bit more involved, but a lot of times we'll be asked to sort of do this preliminary hierarchical type of step first. So kind of armed with the information that
Okay.
oh yeah, sorry.
Sorry, just a question. For the dendrogram, I still kind of don't follow how we are seeing in the output. I mean, so if we kind of enlarge it, I'm still kind of having difficulty as to how do you see the clusters? Is it the way
Mhm.
from one line to another line, or is it like the block? So
Yeah, it's like a jumbled mess. There's no doubt about that. So what I'm looking for are these down lines that account for a good group of a good sized group of respondents. So if I look at this one line here, then you can kind of take the respondents from the little arrow to the left as ones that would sort of group on this point. And then if
okay,
I took this point here, it would sort of take all that are underneath it up to about here. Now it looks like this group here is sort of a small little cluster of, looks like maybe, I don't know, 8 or 10 or
okay,
something like that. And so this little cluster here um, may not be a cluster. It may be just sort of like these folks are or sort of like outliers or something like that. But then it looks like it has another cluster here which is decent, and then a smaller cluster here. So like 1, 2, 3, 4, 5 maybe. If
okay,
we went down another level here, this might be one, and then this here might be one,
okay,
and then this here. So it kind of looks like we have 2 or 3 that are sizable, and then maybe some others that are smaller. It's kind of hard to tell, but basically you're looking for the length and the kind of the degree of these downward like things here, and you're looking for ones that account for a good grouping, a good number, a sizable number of respondents. There's not a science behind this, and there's not a wrong answer or a right answer. It's just kind of like an intuition, and you're not going to get any researcher who looks at this and says, oh yeah, there's definitely four clusters, or there's definitely 8 clusters, or whatever. It just doesn't work that way. It's not interpretable enough. Um,
Okay.
but it gives us something to move forward with, and it's very exploratory as opposed to confirmatory. So take it with a grain of salt. I mean, and I think even the textbook authors will say the same thing, that you know, the amount of information you gain from it may be minimal. You may be able to identify outliers like this, whatever respondent that is. We probably need to try to zoom in a little. I don't even know. I don't know that I can even do it on this, but you might even want to see what that respondent is, who's sitting down there, you know, kind of by himself. These in here are just kind of, it's a small little group there. So I mean, you're going to have a little dash for every single respondent. You're going to have however many is in your sample. You're going to have a little line down here. So eventually you're going to have a line for everybody. But if there's a long drop, that would indicate a respondent that's a bit out of the norm. This long drop here, this respondent here, is definitely a challenge, probably. You know, I would say. So, you know, the idea here is then with the, you know, I'm going to say there's at least 3, you know, groups here, and maybe more, maybe 5 or so, something like that. And that would be maybe a good range to think about in terms of what we're looking for moving forward. I mean, we can, in hierarchical clustering, we can specify a number of range, and it will classify for you, you know, what groups will be in there. But again, if you're going to do a k-means anyways, then I'm not sure there's a lot of value in classifying now as opposed to later. So, I mean, you could classify, you could do like, I could say, look, this is going to be a three cluster solution. I could say absolutely, and I could run this, make sure I've got everything. Sorry, make sure I'm going to, and for ease of my eyes, I'm going to take those off because I don't want to look at those anymore. And let's just, we could save the 3 factors or 3 cluster solution if we wanted to, but again, we'll just run that. And here we've got our cluster membership. You know, we've got these cases in 1. We've got some 3s, we have some 2s in there, and that's kind of it. But again, we don't get a lot of information from this that is truly beneficial until we take that and we move it into some other, either 2-step cluster or k-means cluster is really what we want to look at. And now I'm going to specify, you know, do I want 3? Do I want 4? Do I want 5? You know, how many do I want in this analysis? Remember, the iterations will be set at 10. You can change that if you need to, though. In other words, if you need more iterations, it's okay. But instead of an iteration for every single respondent, it's only going to group and regroup a certain number of times until the respondents don't move anymore. So all the respondents will be evaluated simultaneously in this analysis, as opposed to one at a time. It'll create a solution, it'll run again, it'll optimize as many times as it needs to, or it reaches this sort of this break. Okay. Here again, if I'm going to unclick that, because I'm going to still explore. I'm still going to, you know, kind of try, like, I'm not going to probably settle on one cluster right away. I'm probably going to continue to look at clusters. again, if you do a cluster information, you can click that and we'll get a box. It'll be long because there'll be a line for every respondent. Okay, so continue. Again, I don't know how many clusters. I haven't looked at your responses yet, but your clusters and kind of what you did. So we've got a response here, cluster membership. So initial cluster centers start. We do an iteration check. So it did 7 iterations before before it was stable. So each iteration, individuals are moving, respondents are moving from cluster to cluster to cluster until their distance to cluster centroids, until the centroids are set, their distance to the centers is minimized and their distance away from their cluster is maximized. I don't know if that makes sense, but you're sort of centering in each respondent. And so we asked for each respondent, so kind of how they are done. And again, this is a random sample. Oh no, oh, that's interesting. This box gave us all. No, this should be a random sample. This is a random sample from the selection. This gave us a score, an average score for the respondents in each cluster. So the respondents who were dropped into cluster 1, their average score on each of these variables is here. So you can sort of say, okay, so cluster 1 is high on libertarianism, low on authoritarianism. They're high on the liberal conservative scale. Now, if you go back, and just because I remember, a high score is conservative and a low score is liberal. So it's kind of anchored conservative liberal, or liberal conservative liberal. So if you remember that, then you can kind of just, so it looks like this first cluster is grouping around people who have a conservative perspective, low on authoritarianism, high on libertarianism, and I guess middle of the road, although relative to everybody else, kind of maybe slightly higher on self-determination. This second cluster looks like it's low on liberal conservative scale, so that'd be maybe more of a liberal kind of perspective. They're higher on authoritarian, but pretty equal with group 3, low on libertarianism, and then kind of, I guess, low relative to everybody else, it looks like, on self-determination. The third group looks like they're sort of in the middle on the liberal conservative scale, higher on nationalism, same as cluster 2, relatively speaking, on authoritarianism, middle-ish on libertarianism, and lower, I guess. And I don't know if this is statistically lower, but so there's maybe in the middle. It's kind of a middle group maybe, but an interesting group anyways. So final cluster centers. ANOVA, okay, so this is where the rubber meets the road on each of these variables. Self-determination does not look like it is effective with this particular sample size. Now, I'll warn you, or I'll preface this, once we do the full set, these will all be significant. So if you have a smaller sample size, it'll pop up here as some of these will be non-significant. Sample size will definitely impact whether you get a significance here or not. And this is saying that these are significant in, if we look at the differences in these mean scores across each cluster, it's kind of like it's an ANOVA, and actually this week for MANOVA, you'll kind of see this a little bit more, but it's an ANOVA because it's an F statistic and basically the test is, in this case for self-determination, that 4.13 is equal to 4.1 is equal to 3.84 statistically speaking. And so that's sort of the test. And so what this says is that for this sample, self-determination, it falls above 0.05. So self-determination is probably not a significant, the differences here are probably not significantly different. Whereas all the other variables, there is between the three, all three conditions, it seems like these variables discriminate, for group membership. So that's good. I mean, you certainly want to have variables that are good for you. That's not bad at all. Number of cases for each cluster. So this is important. You want to look at this for some balance. Now you might say, well, that group number 22 is pretty low. And you may not be wrong, but 22 is still a group, out of 180 here that were drawn in this sample. Think of a small cluster as a niche group, as a kind of a small subset. They may not be particularly large in number, but they may still be very much a viable cluster to group in. If this was something like 8 or 10 or 6, if it was really, really small, then we might really question its validity. But that, that's just, kind of what we want to look at there, in terms of the number. And you can kind of go back up here. Group 1 looks like numerically by percentage wise the largest. Group 2's cluster 2 kind of, a quarter of the size roughly of group 1, and group 1 and 3 look like they're almost about the same size wise. So if we go back up here and just kind of look at this, group 1 and 3 out of this draw seem to be the largest, and then this group 2 in the middle were sort of the smallest. So that's kind of, there. Now I wouldn't stop here because this doesn't really cost us anything but a little bit of time. I have no problem. We said maybe we could have as many as 6 or 5 clusters. I don't know. We could absolutely run the analysis, just keep running it and try different things. There's no harm in doing it. There's no reason not to. So this ran, we did 5 iterations. Again, we have sort of the groupings that are here. You don't have to have this table if you don't want to. We have, again, our final cluster centers. Now, obviously, when we have more clusters, they each become a little harder and harder to define. It'll be more difficult to kind of see the differences, the nuances in clusters as you have more of them when you're sort of analyzing them by these means. So, it's actually kind of, you can look at something like the liberal conservative scale. You've got a perfect 7 here. So that is an absolute far right conservative. You've got a 1.89 here. So that's a far left liberal probably. If we're just looking at that one scale, and then you're going to have kind of a whole range. Then we've got kind of, we've got 6 different points on a range here that you can look at. So again, that's great. We can look at that. Notice here, self-determination becomes significant. So we have a greater range of scores, across the 6 clusters on this particular. So what it means here is just the difference. If you took, so one of the things you can do is you can take the biggest number and the smallest number here. So we have a 2.35, and then we have a 4.43, and you look at that, we look at that range, and those are significantly different from each other, and that's what it's saying in this box. So just across all 6 clusters, there's significant difference somewhere. We're not saying that they're all significantly different from each other. We're just saying at least 2 are R. So that's not unusual. I wouldn't be surprised with that at all. And then we've got this whole cluster thing, the membership. Okay, we got 81, 61, 25, and that we got a 2, a 3, and an 8. So those are unacceptably low. We cannot form a cluster from 3 if we have a sample size of 180 here, or 8. Or you'll notice that these are dramatically lower than everybody else, than the other clusters. And so, you know, just there's no justification to have this many clusters just with this group membership thing. So number one, group membership here does not justify this. And number two, the interpretation of each cluster, you have to be able to interpret each cluster at the end of the day. If you can't do that, then that's a problem. Okay, so that tells me that'd be way too many. If we jump back to maybe 4, we could try 4. That might be okay to do. Convergence was achieved. Okay, so it took yeah, and you'll see zeros all the way across here. It took 10 iterations, but we're good. It starts with a spot, and then it just kind of builds on that. Again, this chart here you don't need to have if you don't want to. We can begin to interpret this like we have before with the other ones. Looks like nationalism is pretty, we got a 3.9 all the way down to 2.31. So that's probably, yeah, all of these, if we look, all of these are significant in terms of there's at least 2 pair between the clusters that are there. Group membership, oh wow, this 9, see, 78, 53, 49. Yeah, it's probably going to be pretty hard to say that we have 4 clusters. Now again, we've got a sample of 180. So sometimes you'll see, and we may see it here, sometimes you see if the sample size increases, this may balance out more. It might. And again, as sample size increases, these will become significant just because sample size will influence this, and you'll just see it there. So a couple things. So there's a couple things you can kind of play around with and interpret a little bit. Number of clusters you're asking for, number of members in each cluster, and then the variables that you're using to define each cluster. Extend this out to market research and market segmentation research. You're looking at customers, either their buyer behavior, frequency of purchase, the dollar amount that they purchase, maybe some of the characteristics that they have. You can talk about loyalty and satisfaction scores put in here. If you're doing, so if you're doing CRM and you're looking for loyal customers, if you're looking for, like, you might do something called a customer pyramid where you're identifying your most profitable customers, and they're often very loyal, very satisfied. They have lots of high net promoter score. So you can definitely group customers based on how good they are as a market segment. You can regroup customers based on product features that they like. So like some people want, like if in the beverage industry, some people like diet soda, some people like fruity soda, some people like, I don't know, whatever, you can use all kinds of different product characteristics and regroup customers that way. You can include price as a product characteristic. So there's like a lot of applications and a lot of different ways to cluster customers. It could be, again, a profitability thing or a buyer behavior thing or something like that. So this technique or this data set doesn't really so much lend itself to quote unquote a customer segment, unless, I guess, if you're in the political field, then it would. But the method is the same. And I mean, the method that we're using is the same. Okay, so what I'm going to do then is we split the data, or we selected cases, excuse me. So we had a very restricted set. What I'm going to do is I'm going to take it back to my full set minus those outliers that I identified earlier. Okay, so I'm going to do that. And then what I'm going to do is, I think we're happy. Are you guys happy? Are you guys okay? Well, we'll run it with a 4 cluster solution, and then we'll run it with a 3 cluster solution. So let's just do both. Again, you know, you will have a lot of fun just playing with this. I think that's why I like this method so much, just because, I don't know, you can play around with it. I'm going to save cluster. So I'm going to save the cluster membership this time. So we're just going to create a new variable, and it'll be at the end of the data set. It'll be a 1, 2, 3, or 4. It'll assign each respondent a cluster, and we'll group them. Okay, so we'll run it. We'll do okay. Remember, this is the full data set. So again, 10 iterations. Oh no, it didn't. It stopped early. It was close. It did not do the full thing. So hold on, let's do the full thing. So it needed more iterations than 10, and it's not going to need many more, and probably need 1 more, but we'll go ahead and bump it up to 15 in case it needs it. Run this again. Oh, it still didn't do it. What the heck? All right.
Yeah, Dr. Floyd, I think it needs about, at least for me, it was about 30 or 32 or something like that. Some crazy.
30? Is it, or 32?
Yeah, I was like over 30 something, so maybe 40 would be good.
You know what? It's doing all the heavy lifting for us, so we'll let it.
Oh,
Okay.
it go into 22, something like
Yeah.
that.
That's okay. That's okay. It's, yeah. All right. So we pumped it up there. Again, we're asking it to do a lot, but that's okay. We've got good CPUs nowadays. Its brain is bigger than mine. I know that. So, all right. So we've got these final clusters. So again, if you're writing a customer profile, which is something that you can do for the final exam, if you're doing a customer profile, you can do some, and even for your client projects, you can like describe each cluster in terms of the data. You can do it verbally, but then you can also kind of interject, like, this cluster scored highest on these variables, this cluster scored lower on these variables. And you can do some like bar charts to kind of compare clusters on some of these variables. That's sometimes helpful to do. You might be able to do it right here in SPSS. I can't really remember. Create a graph, a bar graph. I've done this in a while. So yeah, you can do the, obviously you can move this into something else and make a pretty graph out of it if you want. But this can help you visually inspect sort of, you know, these 2 middle clusters are low on the green, which is authoritarianism. We've got this one here is really high on libertarianism, and it's really high on the conservative end of things. This one here, the low orange, means it's low on everything actually, but it's it's closer to liberal than it is conservative. So anyways, there's some interpretation there. Group membership. So this is exactly what I said. You know, last time we did it, that 4th group, I don't know if these are in the same order, but one of the groups was really low. But here, they seem pretty even. I mean, not even, but they seem reasonable. Like, if I looked at the percentages of these, okay, I mean, so it's not the biggest percentage, 147 out of 780, but that's a market. I mean, that's a group I could go after and sell probably if I'm a marketing manager. I could maybe position a product towards them if it makes sense, obviously, for me to do that. Then I could probably make something out of that. So that's okay. I mean, I think if we could run this with the full numbers. The subset didn't really justify it. You know, you still may want to do a 3 a 3 cluster solution just because that's what we were led to believe earlier. Fine, we can do that. And we, yep, okay, so this converged after 25 iterations with a three cluster solution. Lots of numbers here. Let's get down to the bottom of this. We can do another little chart here, just quick and easy, and just kind of see. So this looks like our conservative group. These two, this is an interesting one where libertarianism is high, and this is kind of lower. So this is probably more the social liberal type of a group. It's kind of hard to interpret a little bit. Authoritarianism tends to be strongly associated with liberalism. So that's why these green and the orange are fairly close. That's why I would push them more towards the lefter side of the liberal group, and this is probably more the center of the liberal group, is kind of, or maybe the center of the spectrum, maybe is cluster 1. You have to do a little bit more analysis, and hopefully you have some other data to kind of support you. Oh, so this is interesting though. Self-determination is not significant at this point, and nationalism is not significant at this point. So there's 2 variables that don't appear. So this is probably the blue it's looking like, and the yellow on the bar charts. So the blue, yeah, self-determination, and the yellow is nationalism. If you just look, these are fairly even. And if we looked at the actual data right here, 2.67, yeah, those are very, very even, and these seem to be even enough. All right, so that's kind of interesting that libertarian, authoritarian, then liberal, conservative, those are the variables that kind of kick out there. Very even groups, it looks like, in terms of the clusters. So there you go. So yeah, you can decide how you want to present that. Next step here, again, confirming things, switching up a little bit. We can go with that. Now that we have group memberships, so now it's not so much exploratory because we've formed groups and we've assigned groups. So now we can jump into maybe a discriminant analysis. And again, this really isn't so much needed, but it's something that we can do. It sort of affirms what we've found. And there's a pretty graph at the end, I guess, is the best way to think about it. Now I'm going to take out, though, these 2 variables because they were not significant. We could leave them in if you wanted to, but I'm going to take them out just because they weren't significant there. I think the last one we did here was a 3 cluster solution. So we're going to go with this last one that was created. The last variable here created was a group membership variable. And it was the 3 cluster solution. So I think we should have 1 through 3 there, right? I think that makes sense. We'll see if that works. We'll do discriminant analysis and then get something like this. No, that's kind of interesting. Okay, yeah. So we're cross-validating. We're accurately predicting groups by 63%, 98%, and 70%. Groups 1, 2, and 3. Just visually, because we're here on the output. Visually, this number 1 cluster is definitely a middle of the road, but they're also bleeding in heavily to number 3. And then number 2 seems very well defined in terms of just a visual appeal here. Number 2 seems very tight and very, very solid. Blue is kind of clearly in the middle, but you see a lot of just blur between 1 and 3. Group cluster 1 and 3 seem to just kind of, and I think if you see there's probably 63% of 1s and 70% of 3s, were classified correctly. 98% of 2s were classified correctly. So there's a little bit of, so like overlap. So if I was going to create a product, I'd probably say, well, look, let's create a product that, and we'll treat groups 1 and 3 similar. And I may launch a product in both of those market segments. I might make some nuanced changes to it, or maybe do an ad appeal or whatever the positioning strategy I have. I'm probably going to, you know, kind of, if I hit 1 and 2, I'm hitting 2 good market segments, but my product and my positioning probably doesn't have to be that well defined to distinguish between the two. I might be able to, in other words, lump them in together. I really would have a problem selling customer market segment 2 the same way that I'd, you know, kind of approach segments 1 and 3. It's kind of a way I'd probably look at that if I was thinking about this from a marketing perspective, you know, sort of above and beyond the whole, you know, just let's do the number crunching type thing. There is a little bit of what the client should think about doing as well. These are the functions, these are, yeah, okay, these are prior probabilities, but we should also have the functional coefficients. So for future prediction of group membership, we would use, you know, this is the chart that we would use. These are the weights that we would use for that. You know, if we use we want to be better than 25% rule, then we're clearly doing well in classifying these groups, even though there are 2 groups that are a little bit lower and the middle one is just nearly 100%. We're still doing pretty well, as opposed to just by chance grouping these respondents. We did 2 functions because we had 3 groups, so we did 2 functions, and those are the functions that are there. Want to look at, yeah, okay, that's it. That's what we should have. Sorry, yeah, anyways, that's, I mean, it looks pretty good. It looks pretty neat. Now, in fairness, we cheated the system quite a bit, because we formed clusters on 3 different variables, and then we used those same variables to describe the clusters in discriminant analysis. So these should do really well, shouldn't be really a problem. I think we could also run the same analysis. We could do it if we did the 4 cluster solution. So I think this was the 4 cluster solution maybe. And we could also add back in some of these variables. Oh, whoops, I made a mistake. I took out the wrong variable earlier. I kept self-determination in. That's why it didn't do so well. I had removed liberal conservative. That's the best one. Anyways, we're running it again. We'll do the 4 factor solution or 4 cluster solution. You have lots of good results here. Yeah, 99%, 89, 96, 92%. Do a 4 cluster solution. We got pretty groupings there. They look real good. So yeah, so that's kind of the idea of this in terms of you know, this exploratory stuff. It's kind of fun. Last question here: examine each cluster in relation to brands on the fruit candy product category. Is there significant difference between groups? Starburst, Skittle, Lifesaver, you know, kind of on those. So if we did something like a compare means, probably, maybe we do like an ANOVA on this, something like that. And what we want to do is we want to use our clustering. So we'll do our 3 cluster group. So that'd be our, that just happened to be the last thing we saved. So that's going to be the factor. And remember, this is like an attraction. So we'll do Starbucks, Skittle, Lifesaver. We could do any of these. I know later we want to do maybe the Wendy's, compare and contrast your market segments or your clusters based on that. And in this here, oh no, we don't need to do that. We can certainly do, let's see, do we need to do 2K, Chef A, maybe options, where are my options here? Oh yeah, descriptive statistics. That's really what I want to make sure I'm looking at that. So we're going to do something like this with an ANOVA, and here are some of the descriptive statistics between the 3 groups. Honestly, again, this is like an exercise of just kind of walking through some of this. I'm not sure political affiliation has anything to do with attraction to fruity candy. I don't know that it should. If one of these brands positioned itself to like a political cause or something like that, okay, but that probably would be kind of odd. I mean, I don't think that would naturally happen, but the data suggests something otherwise. Actually, it's kind of funny. It looks like if you just look at the ANOVA, it looks like there is a difference in groups. The mean score of attraction for each of these 3 products is statistically different in some capacity, according to the ANOVA. You know, we can look at these like 3.22, 3.3, and a 2.89. So for Starburst. So group 3, some reason is less attracted to Starburst than the other 2 groups. And there's statistical difference across these means, you know, according to the data. Now we have a very large data set, so keep that in mind. That could be pushing some of these statistical significances. If we reduced our data set, or you know, it might be the case. It looks like they are, group 3 is also a bit lower in their attachment to Skittle and much lower to the, so apparently group 3 just simply is less attracted to fruity candy than the other 2 groups. I have no explanation as to why. I have no idea, but if I was a fruity candy company, I might be less inclined to position my product towards group 3, maybe. I don't know. I have no idea what group 3 is or who they are, but that would be like that. So just looking at that, and then looking at between group, like between levels or clusters here. So we can dig deeper in the post hoc test to really kind of uncover where some of these differences might be. So remember, we have 3 clusters, so you can do a post hoc test. If we only had 2 clusters, you wouldn't need to do it. Really to identify it. Yeah, the F test, the F statistic only says in the ANOVA that there is a significant difference in some relationship, but it doesn't define which relationship. So for Starburst, the difference between group 1 and group 3 is where it is. In yeah, group 2 and 3 as well. So 3 significantly differs from 1 and 2 on Starburst, and we kind of see that up here. So 3, it significantly differs from there. Now group 1 and 2 do not. So again, here's a case where I might lump group 1 and 2 together if I'm trying to sell Starburst, because they basically attract the same amount to the same degree as each other. Um, for Skittle, again, group 1 and 3 differ, and a group 2 and 3 differ. Yeah, same thing. Lifesaver, same thing. 1 and 3, and then 2 and 3, and then 3 and oh, yeah, and then one. So same thing. Now, if you had a 4 cluster solution and you ran this with 4, then you would, you'd have an extra layer there, or an extra line for each one of these to address, and that would be okay. You could do that. You could do that as well. So yeah, so just looking at attraction towards candy, and then we can also compare and contrast your most and least attracted market segment. So we could look at Wendy's as well. So with this, let's see here. Compare means, oh no, I don't want to do that, sorry. We really don't need to do so much. We can do, I don't know if we can do that. We can do just when. I can't remember what the best way to do this would be. And when we're looking at Wendy's, how this will, yeah, that's not really Wendy's. So Wendy's, if you look here at Wendy's, we've got 3 groups. Boy, this poor group number 3, they just don't do anything. They don't like anything. I don't know who they are, but they're just not attracted to a lot. We have some distinction here. There is some distinction between groups. It looks like group 3 would be the least attracted to Wendy's. And then the other 2 groups are more or less the same. So I guess the same kind of conclusions could probably be made. It's interesting that, again, group 3, I don't know what group 3's average attraction score is. And if you did a 4 cluster solution, again, it's going to be different. You're going to look at this a little bit differently. The results may be a little bit different. And then you can kind of go in and describe group 3 maybe, and go from there. Yeah. All right, so that's kind of, again, these added on sort of analyses. I'll be honest, sometimes I'll take a data set and I'll just start running a few things, and something will be interesting. I won't necessarily be looking for something. One thing I will say, so when you're doing your final exam, and or it doesn't matter if you're doing your final exam, but another add-on, I meant to mention this. When you look at this size here, if you do have clusters that vary in size, so in other words, these clusters are actually fairly even, like there's a fairly even distribution. I mean, 297 is clearly much more than 230, 239, 240, but there's not a wide variation here in group size. Keep in mind that N does matter. Let's say, for instance, we had a cluster and we had like 230, 300, 240, and then let's say we had another cluster that was like 100. It's a good number, but it's a smaller sample. So like if you advocate, hey, you should really go after like this cluster, they may be really super attracted to your brand, but it might be a small cluster. That's something to know. So like, cause I'm worried as a manager of like number of sales, profit margin, like revenue, what am I gonna, like the volume of sales and revenue and sales and stuff like that. Well, the end matters. Like if you tell me you might not make as much money, but you're going to serve 300 customers, as opposed to, yeah, you're going to make more money per sale, but you're only going to have 100 customers. I mean, that's a big deal, from a manager's perspective. That they may be a small boutique and they may want 100 as opposed to 300, or they may be, a company that has real low margins and they really need more foot traffic. They need volume as opposed to anything else. And so that 100 segment may not be very attractive to them anymore. So don't lose sight of this idea that this end, it actually means something in terms of the bigger, in the bigger scenario, in the bigger picture. We could actually rerun this. I think I can rerun this. I think this variable here, the second to last assignment, it had 4. So we're looking at this 4. We have 4 clusters, one of which has 265 members, one has 146 members. So not quite half, but quite a bit fewer than the number 1. This number 1, number 2 has the highest, attraction to Wendy's, and these others have a little bit less. So, I don't know, maybe that matters, maybe it doesn't, I don't know, but it's something to have a conversation over. If you have one group, maybe that's particularly small. In this case, it doesn't work out. The smallest groups actually have the weaker attraction rate, but that doesn't always have to be the case. And actually with this ANOVA, it's interesting. When the 5, they're not significant. There's not a significant grouping here or difference between means, as it turns out with this. So, that's curious. But anyways, so that's kind of the assignment. I hope you had fun with it. Again, I know there's a learning curve for all of these, so it is what it is. I encourage you to continue to practice with the data sets that we have. Do you guys have any questions at this point? All right, so I'm hoping that this is beneficial. Now, as we move into this next week or this week, MANOVA, because I think you have some familiarity with ANOVA, I think that ANOVA skills will come right back to you. I mean, I think that they'll be, fairly, you'll be like, oh yeah, between groups, we have to have a factor. In this case, so like the videos and the book will really clearly talk about this, but like the variables get swapped. And so when we refer in MANOVA, when we refer to, and ANOVA too, but when we refer to the dependent variable, like if you're talking about regression, the dependent variable is influenced by the independent variables, and it's like the Y. So like things get swapped around a little bit conceptually when we do MANOVA. So like if I have a bunch of metric variables that I think groups differ on, the metric variables, the continuous variables, they'll be ratio or interval. Those will be our dependent variables. And the grouping variable, the factor, will be our independent variables. So when you're running the analysis, when we're actually doing this, we're going to go to analyze, and then we're going to go to general linear models for a MANOVA, and then we're going to go to multivariate. a GLM. And so in this case, I've never done this, so I don't know if I'll find anything, we'll find anything or not here. But here, we'll put party in. That's going to be, we'll put party in just for fun, just to see what happens. And that's going to be our factor. And it's going to be, so, but it's going to go in here and it's going to be treated like an independent variable. I mean, that's kind of what it is. And so like, think about this as an experiment. In an experiment, you have groups. You have somebody who received a treatment. You have some of your respondents receive a treatment, some of them not. Some of them maybe receive a different treatment. You might have 2 treatments and you might have a control group. And so we might have 3 groups. So we're controlling who has what and who gets what treatment. We're controlling those, and those are independent variables that we're actually controlling, and we want in an experiment, and we want to identify the effect of that control or of that on our dependent variables. So our dependent variables depend on what we did in our factors. So this is not really an experiment because we didn't control what party a person was in or identified as, but we're going to call that our factor. And then we're going to put in some of these variables that we know will work because we've used this a lot. So these will be like these continuous variables. And when we do this, we're not really going to worry too much about the model here, although some people will kind of look at this type 1, type 2, type 3 thing. We don't need to worry about that. Don't really need to worry about too much here in the plots. I think we can make a chart. We've got more than one level, so we can do a post hoc test. And we're going to do a chef A test on that. What else do we need to do? No, we don't need to worry about that. We don't really need to worry about saving stuff at this point. Now, again, I haven't done this with this data set, so I'm not sure what we'll find. We'll do descriptive statistics, estimates of effect size, observed power. You absolutely want to do a homogeneity test. And again, the text and the videos will talk about assumptions, and homogeneity is, it's hard to achieve, but it's supposed to be there. So that's that. And so that's kind of how you set it up. That's how you set up the MANOVA. Now, how it's going to be distinguished from an ANOVA is that these, first of all, your fixed factor will have multiple layers, like, well, an ANOVA can do that too. But what'll happen is these will be run simultaneously. The tests will be run simultaneously on the dependent variables as opposed to separately. So in an ANOVA, so we can do an ANOVA, the exact same thing, get a lot of the exact same results on a variable by variable basis. But what a MANOVA will do, will run them together, so you'll see kind of like a group effect. The other thing that a MANOVA will do is it'll allow you to add additional fixed factors. So I might put gender in here as well, and you can't do that. And then what you'll get is, if we did that, you'll get an interaction estimate, an estimate of effect for the interaction between party and gender. And you can see if that has, and that would be kind of like a moderation, kind of a moderation thing that's going on there as well. Okay, so that's kind of, again, if you're cool with ANOVA, then MANOVA is not a stretch. It's something that's palatable, that you'll have fun with, you'll be able to do. So in this case, we'll have 6 different groups. So there's 6 different groups of respondents. We have Republican, females, Republican males, Democrat females, Democrat males, and then neither political party females and neither males. So there's actually going to be 6 different groups here. We have the actual, like, so on each of these variables, we have 3 variables: libcon, authoritarianism, and libertarianism. And we have the means for each of these groups. So there's a male and a female for each of these 3. So there's 6 means for each of the variables, and so those are listed here. And then we also have our sample. So these aren't going to be equal cells necessarily, and that's okay. I mean, that's kind of the way it is. So we have 187 in one cell, 133, then we have a 150, a 64, and then a 137 and a 102. So 64, okay, well, that's what we have, so that's what we have. And so that's there. Now, 2 different tests of homogeneity will emerge. One will be the Box-M. This is supposed to be interpreted in reverse, and so is the Levine's test. So so this says, like, so what you want is something 0.05 or higher. So clearly there's a challenge with homogeneity. And so what we're doing with homogeneity is we're saying that the variance in one group is equal to the variance in another group, and the variance in all the groups on each variable are the same. So in other words, I've got 6 groups, and so if they're if the homoscedasticity assumption is made, then what it means is that the variance in the data across all 6 groups is the same. Now, that's pretty hard to achieve, especially if you have more groups. If you have fewer groups, that may be easier to get to, but with more groups, it's harder. And again, this can be a very difficult standard to reach. So I wouldn't let this stop your analysis, but it can be something you're concerned with. So I'm just dropping down here to Levine's test. So this is the other, so boxes M and Levine's both test for heteroscedasticity. And you'll see here that in some variables, so like for libertarianism, it would appear as though there's equal variance across all 6 of our groups on the libertarian scale, but it's not met with these other 2. So the boxes M is like a global score of heterogeneity. Levine's test drops in and gives you a test of heteroscedasticity for each variable. So you can kind of see where things are breaking down. Again, I wouldn't worry about that today or for your assignment or kind of where we're going, but just know that that's something that is kind of we want to look at. Now, the other thing is there will be 2 other big boxes here that you're going to look at primarily. This box here, the multivariate test, and this is, we're going to look at party, gender, and party and gender, and you look at party and gender first, because this is the interaction. If there is an interaction, then this will be significant, and it will mean that, like in this case, gender plays a role in whether someone is one of these political parties or not. Okay, so like there's an interaction, or the reverse, your political party helped to determine your gender. Now that's a little silly because that can't happen, but the reverse can. Or the reverse may be predicted. This is not significant. It's above, well above 0.05. So what this is saying is there's not an interaction effect going between these factors to worry about. So we can interpret these others as significant in and of themselves. So on their own, party and gender, there's going to be significant difference between the means on party and gender across these 6 groups. So what we're probably going to find down here. And then we drop down to the second big box that we're going to look at. And then we're going to look specifically at party and specifically at gender. We can look at party and gender here, but we already looked above as a group. And, you know, for each level of kind of what we're looking at here, we're finding that these are all, oh, well, authoritarian is not significant in gender. Okay, so there's one level of one variable that's not significant. The means are not significantly different, but all the others do appear to be. We got to do some post hoc testing, and yeah, I don't think there's anything that we're really going to worry about there. And then charts. There should be what? Yeah, the three charts. Mean scores on the liberal con scale. Remember, a high score would be conservative, a low score, and then the middle. So those are kind of like just maybe undecideds or people in the middle. The low would be liberal, the high would be conservative. Again, liberals and authoritarian scales tend to go together, whereas libertarian and Republican tend to go together. They just do, and then neither is kind of in between. And so that's kind of what we would certainly expect. All right, so it's like we're doing a bunch of ANOVAs, but we're taking into account a system, and we're taking into account multiple factors, if you have them. That's what MANOVAs are all about. And again, it's just an extension. You're just extending ANOVA by doing this. And that's what it'd be. So the homework assignment, for this week is just kind of that. We can look at it just real briefly. I know you'll take a look at it yourself. I added a data set. So this is kind of a cool data set, actually. It's a data set where respondents looked at one of 4 different advertisements, and the advertisements were manipulated by product and by message appeal. So one of the ads was a storytelling ad for a car. One was a storytelling ad for extra gum, for gum. One was a straight sell appeal for a car, and then a straight sell appeal for gum. So we had a 2x2 type of a thing. There are 4 groups. So you're going to have 2 factors. You're going to have the brand or the product type factor, and then you're going to have the advertisement type factor. And then we have some outcome variables that are here as well. So we have some metric scales that are described here. So what we did, again, in the data set, so you have the data set. It's a good, solid data set. There's a lot in it. Evaluate the metric data for the MANOVA assumptions. So, kind of come up to speed on the assumptions, which are pretty similar to the things that we've already been doing when we look at data set. Make any adjustments if you feel it's appropriate. You may look for outliers. There may be some in there and such. Run the MANOVA with the brand, which is the product. So it's either Mazda or Extra Gum. So it's Mazda car or Extra Gum. So run it with the 2 factors as the independent variables or the factors, and then we have some dependent variables. So these would be the dependent variables that we do: likelihood to watch versus skip, net promoter score, and purchase intention. Okay, and then you want you to interpret the interaction because we got 2 factors, and this is something that is good. We want to interpret whether the product type, brand, or gum factor matters, and or whether the ad type matters. And then also there's going to be something, I didn't mention the partial eta squared, but I will. In your analysis, you're going to get a column here in two places, in the multivariate test in partial eta squared, and then also between subjects table here gives us the line by line effect for each of the dependent variables by each of the by each of the factors. But the partial eta squared here, so we've got all these, we know they're significant, but what it says is that like this one here, liberal conservative, so there's like a significant difference across parties, cross party affiliation on liberal and conservative on that scale. So the mean score on the different levels, is significantly different in some place on liberal conservative. And what the partial eta squared says is, the way you say this is 46.5% of the difference in mean is explained by this scale, by liberal conservative. So there's a difference between these parties on these items, and 46.5% of that difference can be explained by the liberal conservative scale. Only 8.7% can be explained by the authoritarian scale, and 21.8% of it can be explained by the libertarian scale. So just so you know, those are pretty high numbers. Those are pretty, like 46% is a big number. 8.7% is a pretty small number, but that's what this eta, partial eta squared is. So as you're doing your reading this week, and as you're kind of investigating this method, make sure that you're kind of aware of that and just kind of know what's going on. When you look at the multivariate tests, there's four groups of tests that always come together: Palais, Wilks, Hotellings, and Roy's. There's some speculation that they all come out very similar a lot of the time. But again, you'll have this partial eta square here that kind of helps you understand. So gender as a group only explains 2.2% of the variance, or of the difference of means, this whole data set across the 6 groups that we have, because this is at group level data. Party explains quite a bit more. So gender doesn't seem to be that effective. So like if you're going to try to understand group differences in these 6 groups, we included gender, but it's not that impactful. And in fact, if we go down here, I think we see some of the gender items, not specifically the items here, not really producing a lot of influence on mean differences. Okay. All right. So anyways, this is kind of like a brief introduction on MANOVA and what we're doing there. And the assignment should be pretty straightforward. It gets your hands dirty. It gets you into this analysis. If you want to open up some of the other data sets and find some factors, just run some. You can. You're welcome to do whatever you want. Certainly the text uses the HBAT 200 data set. So feel free to use that and just play around, follow along with the book if you want, and just get real comfortable practicing this. That's the best advice I can give you as far as running this stuff. So so we talked about the homework assignment. I'll be wrapping up the grading here getting that stuff to you. I know I'm about a few, maybe a week behind on that. So that'll be coming quickly, fast and furious on that. We talked about this week's homework assignment. We talked about the final exam. Shoot me some times that work for you to do the oral. It's kind of a first come, first serve basis. I can tell you that the daytime is great. I know your schedules may be all over the place, so the daytimes are generally good. Thursday and Friday daytimes are not good as much because I've got to be in the car both of those days. But let me know how things are going. Let me know how you're finding everything. If you have any questions, I'll try to get to you as quickly as I can. Anthony, I'm sorry I was a bit late, but you were kind of right on that. So otherwise, do you guys have any questions, or are you sinking or swimming? Hopefully everybody's swimming with the heads above water. We're all doing good. I think
Doing
everybody's
okay.
all right. Cool. Well, so not to deviate too much, but we wrap this up, and then we have boot camp this year, this fall, August 24th through that week, whatever the Monday the 24th. So I'd love to invite you to boot camp. We have 8 or 9 students coming in, and I'll get you information about that, even though you may not be registered in that class. I think all of you have had boot camp, right? So you're not required to sign up or anything like that, but it's kind of a tradition to meet the new students and to kind of get together. So I'll let you know when that is, and that'd be cool. And then I think most of you may be in 5:30. That starts that next week. That'll be a hybrid class. The way it is written right now, it may change, but the way it's written right now is that we meet on Mondays face-to-face here on campus. And so it's a hybrid course for 7 weeks. So we meet 7 times face-to-face. That's the class I teach in the fall. So, and I think you guys are probably enrolled in that, or maybe going to be, or I'm not sure. Riley, I think you're not there. David, I think you've been in that. So maybe not everybody, but that's going to be here before we know it. I mean, that's like right around the corner. So we'll wrap this up. Batul?
Is that a required class?
Marketing 5:30 is required. Yes.
It's required, right? Okay.
It is.
Yep. Okay.
Yep.
Thank you.
Yep. Yep. It's
I just checked my schedule. I'm in that class too. 5:30.
Yeah, that's what I wasn't sure if it's required. I know because I just enrolled in it, but yeah.
So just we follow CougarNet on that. There might be an issue. I don't know. I have no idea. I just found it today. The enrollment for that class is probably going to be 14 or 15, something like that, or 16. And the room capacity is 12 because of COVID. So they either need to find us a new room, or if there's not another room, they might shift us to like this, where it's online, but maybe synchronous. So we meet at that time, but it be online. I don't know. I can tell you I'm on campus at least 2 or 3 days a week, and there's absolutely nobody here. I mean, it's like a ghost town. We can easily socially distance. I mean, it's not an issue whatsoever. It's safe. But we'll obviously be careful, and whatever rules they assign, we'll go with. So as of right now, there's a small question mark because it was just because we don't have really technically a room to be in. And again, if we do it online, the way I do that class will change a little bit. Maybe, I don't know, because it incorporates a significant amount of conversation and discussion. And this me just dialoguing won't work for that class. It just doesn't. Because we do cases every week and we do group presentations. And so anyways, it's a good class. I love it. But it's much more fun when we're together. So anyways, let me know, shout out, let me know if you have any questions. Obviously, when you start to look at the exam, if there's something like in the questioning that you're not sure about, let me know. If you ask me how to do something, I'm probably not going to be as receptive. But if it's a clarification, I want to be as clear as possible so that, you know, you guys are comfortable in doing the right stuff. It's not meant to be tricky or anything like that. That's not ever the case. So otherwise, any other questions before we wrap things up? No? Okay. Well, let me hear from you. Especially shoot me some potential times that might work for you for that oral, and we'll go ahead, first come, first serve basis, and we'll get that knocked out. All right. So we'll see you. Take care. All right.
Thank you.
Thank you, Dr. Clyde.
You're
Bye.
welcome. You're most welcome. It's good to see you all as usual.
Yep.
All right.
Have a good week.
Have
You
a good
too. All righty.
Bye.
Bye.